Hey everyone! Today we're jumping right into one of the most important tools in all of Python. I'm talking about lists. Seriously, you're going to use these things all the time, so let's get to know them inside and out. So let me just kick things off with a question for you. When you're programming in Python and you need to handle a collection of items, what's that one go-to super flexible tool that pops into your head?
Yup, the list. You probably saw that coming. It is the absolute workhorse of so many Python scripts and applications for a good reason.
Okay, this definition right here is actually super important, so let's break it down. First, ordered. This just means that items stay in the exact order you put them in. The first thing is always the first thing. Second, they're mutable. It's a fancy word, but all it means is you can change the list after you've made it. You can add things, remove things, swap them around. And finally, heterogeneous. This means you can mix and match data types. You can have a number, then a word, then another list, all inside the same list. Pretty cool, right?
So, because lists are mutable, we've got a lot of power to change them. Let's start with the most basic operations, getting stuff into and out of our list.
To add just one thing, your go-to method is almost always going to be .append. It does exactly what it sounds like. It just sticks a new item on the very end of the list. Simple, clean, and, as you'll find out, really fast. But what if you need to be a little more surgical? What if you want to put something right in the middle or at the beginning? Well, that's where .insert comes in. You just tell it the position, the index, and what to put there, and Python handles the rest, shifting everything else over to make space.
Now, what if you want to add a whole bunch of items from another list? You could write a loop, but the more Pythonic way, the way that's cleaner and clearer, is to use .extend. You give it another collection, and it unpacks it, adding each item to the end of your list.
And this brings us to a super common mistake, so you'll want to remember this. Look at the difference here. If you use .append with a list, it adds the entire list as a single nested item. See that? You get a list inside your list. But .extend on the right, that's what you want if you're trying to add the elements from the other list. It keeps everything nice and flat. It's a small difference in name, but a huge difference in the result. Okay, so adding is covered. What about taking things away? Python gives you 3 options, and which one you use depends on the situation. If you know the position of the item you want to delete, you use the del keyword. If you know the value of the item but not its position, you use the .remove method. And here's the cool one. If you want to remove an item and do something with it, you use .pop. It pulls the item out of the list and hands it back to you. All right, we've put all this data into our list. Now, how do we get it out? You can always grab one item at a time by its index, but Python has this amazing superpower called slicing that lets you grab entire sections of a list all at once. So the syntax looks a little intimidating at first, but it's really simple. It's always start, stop, and step separated by colons. Start is where you begin, stop is where you end, and here's the key thing to remember. You go up to, but you do not include the stop index. And step is how many items you skip. You can also leave any of these blank. So for instance, if you wanted to grab a few items out of the middle, you'd specify a start and a stop. So my list square bracket 1, 4 gives you the items at index 1, 2, and 3, but it stops before it gets to index 4. And this is where it gets really elegant. If you want to start from the very beginning of the list, you can just leave the start number out completely. Swait/3 just means give me everything from the start up to index 3. And the same exact logic works for the end. Just leave the stop number blank. 2: means start at index 2 and just go all the way to the very end of the list. Super handy. Now, for a classic, super clever Python trick. If you leave the start and stop blank, but you make the step a -1, you get a reversed copy of the entire list. It's this beautiful one-line piece of code that everyone loves. And importantly, it gives you a new, reversed list without messing up your original. Okay, now that we've got the essentials down, it's time to level up your code. If you want to write code that looks and feels like it was written by a pro, code that's cleaner, easier to read, and usually faster, you have got to get comfortable with list comprehensions.
I mean, just look at the difference here. On the left, you have the old way. You create an empty list, you loop, you append. It's 3 lines, a little clunky. On the right, you have the Pythonic way. It does the exact same thing, but in one single, beautiful, readable line. It's almost like reading a sentence, giving the square of x for every x in my numbers. This is a real game changer.
So we've spent all this time talking about how great lists are, but they're not always the perfect tool for the job. And a really big part of growing as a programmer is knowing when to use a list and, just as importantly, when to reach for something else in your toolbox. It all comes down to what you need. A list is your go-to when you need an ordered collection of things that you know you're going to have to change later. A tuple, on the other hand, is for an ordered collection that you want to lock down, data that should not change. And then you have a set, which is all about uniqueness. You use a set when you just need to know if something is in a collection or not, and you don't care about order or duplicates. And that brings us to our final and maybe most important idea, performance. We touched on it a bit, but as this quote says, not all list operations have the same cost. Sticking something on the end with .append is super fast. And that leads to the big question. You now know how to use a list, but operations like .insert or .remove can get slow on really big lists because Python has to shift a lot of data around. For a list with a dozen items, who cares? It's instant. But for a list with 1 million items, that's a different story. The next step in your journey is learning to ask yourself, at what point does performance actually start to matter for what I'm building? And understanding that, well, that's what separates code that just works from code that works well at any scale.